basically it's a take on the Walter Seagal, an architect who his whole ethic was that you'd have a small profile on the ground itself, so that you'd have four piles and the floor would be suspended on those, and then you'd build your timber frame from the floor up. So there's less of an intrusion environmentally and less of an intrusion, I suppose, generally on the landscape, and it's easily removed or easily moved on if you wanted to. It's cheaper as well. There's less of a foundation that goes in, and foundation would be in wood. We put the frame in. It's not quite a take on the Walter Seagal type house because he would have had upstanding post and beam construction, but that's just a frame construction at the bottom, and then we built the frame around the bottom frame itself. So it's standard 4x2s, standard framing, 400 centres, ladder type roof, which would be insulated on top, and the wall will be insulated up the side from inside, but then the floor is insulated, so the entire cavity will be completely insulated, so high level. You can add on stuff and on the outside if you want to increase your U value. You can get a U value of about 0.19 if you use some of the more modern type installations, but we hope to get up to maybe 0.2 to 3 or 4. So like that's me.
Okay, so yeah, what we're doing is with this place is we're trying to make it into a little bit of demonstration of the different techniques and things that we're talking about on the green building program. And so I brought down this little model of what the wall construction is going to look like. So what we're doing here is it's a system where we're not going to use vapor barrier, we're not going to use vapor control layers, and so we're not going to seal it in the normal way. So what we're doing is we're putting the racking strength on the inside of the house rather than on the outside. So the smart ply is going to go on the inside, and that's what's going to give it the racking strength to give the building actual integrity. And because the smart ply is not very good at letting vapor through, we're kind of stopping a lot of vapor getting out into the wall, which means we don't really need to have the vapor barrier. But then if we're going to allow a certain amount of moisture into the wall, we have to make sure it can get out of the wall. And so on the outside we've got this soft board here, and so that gives us about the 5:1 ratio we want. So if any moisture does get in, we're fairly certain it can get out. But the other great thing about the softboard is that it's stopping any thermal bridging, or it's slowing down any thermal bridging via the stud work. So obviously we've got insulation in here, and in this model it's cellulose, but we're going to put lots of different insulation in this demonstration thing. But the softboard is making the heat path through the stud work a lot more difficult. So that's the idea of that. Because this is a demonstration building, we're actually going to use lots of different materials. So the idea is we've got the softboard up to here, but in here we're going to have perspex viewing panels, and we'll be putting different materials in each of the panels. So we've got some hemp insulation here, we've got some wood wool insulation, we've got some cellulose insulation, and we've got some fleece, some sheep's fleece insulation there. So basically each one of these studs is going to have a different insulation. And it's really just to demonstrate it so that people coming in and out of the college are going to see what's available and the different materials. And then we're going to put a sedum roof on it. It's going to be either a sod roof or a sedum roof at the moment, cost dependent and stuff like that. And then that will be insulated on the outside to make sure that all the timber work is on the warm side of the insulation, because we don't want condensation on any of the woodwork. So we're going to make sure that the woodwork is inside the warm envelope. So just to run through, because we're making it into a demonstration building, as I say, this wall is going to have the different insulation in it, in different panels, and it's going to be clad in just an overlap wood board on this panel. So we've got the insulation, the viewing panel, and the wood board. This one here is the final skin on this wall is going to be the eco slate that I was showing you in the class. So we're going to vertically hang the eco slates just to demonstrate those, because we can't use them on the roof. The back wall is going to be an exterior render system, which is one that the college here does all the time anyway. So they're actually working with this system. I'm not quite sure on the details, but it's using this Putex. Yeah, I'm really not sure about it. But the lads from the college do this all the time on people's houses. So we're going to demonstrate that on the back wall, and then on the front wall, round by the door, that's going to be the most natural of the walls. So we're going to make the wall thicker there, and we're going to do a clay straw mix. So we'll be getting normal straw, and we'll be coating the straw in clay, and then we'll be putting a temporary shuttering in, and we'll be packing the straw into the temporary shuttering and coming up. And then once that's dried out, we're going to do a lime render on the outside. So we're going to have a lime render face, a wood cladding face, a eco slate face, and an acrylic render face. So hopefully we're demonstrating quite a few things, and with any luck we'll be able to come back and we'll be able to throw a thermal imaging camera on, and we'll be able to see which wall, how the different walls are performing and everything. Now obviously if this was a house, we wouldn't be using 4-inch studs, we'd be using at least a 6-inch stud, but that would have been too expensive, and it wouldn't even be very sensible to do such a big wall on such a small building. It would be a waste of the footprint of the building. So it will just be, we're just using a 4-inch stud, and due to financial constraints, plus the fact that it's what this college does all the time, they're training people to do insulation, and it's a valid thing to be doing anyway. All the walls that are not expressly showing one of our eco products will be done with fiberglass. So the floor's got fiberglass in it, for instance, and that's just down to the way it's gone with the materials here and stuff. And also, I think one of the demonstration windows is going to have the polystyrene beads in as well, because again, it's what they do at the college here. They go out installing the polystyrene beads into houses. So that's about it, really. We've just got to get on and do it now. So,
great.
Yeah. Okay.
Thanks a lot, Mike.
Yeah.
Yeah, that's excellent.
So,